In 3.7, we have yet another derivative rule to talk about. This time, we're going to talk about the chain rule. So let's just get right into it. Suppose that we have y equals f of u, where u is equal to some other function g of x, where we have y equals f of g of x. This part right here has a fancy name. It's called a composite function because you have a function here, g of x, that's inside of another function, f of x. So what you'll see is it'll look like you have one function inside of another function. So if I want to take the derivative of this composite function, I can use a couple different notations. I can say dy dx is equal to dy over du. So this part right here is the derivative of y with respect to u times the derivative of u with respect to x. I kind of like this notation, but I actually have another one that I'm going to show in just a second that I think is probably easiest to understand. You can also say the derivative of f of g of x is f prime of g of x times g prime of x is another equivalent notation. It just looks a little bit different. What's going on here is you're going to take the derivative of the outside part, inside part stays the same, times the derivative of the inside part. You can also, if you really like this notation, and I actually kind of prefer that notation, I kind of like using y equals f of u, then the derivative of y prime would be equal to f prime of u times u prime. And I actually think that this is probably a really nice way to write it. This is my favorite way to write it, my favorite way to teach it. So this is probably the notation that I'm going to be using most often in our class. But if you prefer the other notations, of course, you can feel free to use those. But I want to talk about using the chain rule here in particular because I think that using the chain rule is a little bit less straightforward than, say, the product rule or the quotient rule or something like that, where it's kind of just a straightforward power. When you're working with the chain rule, it's a little bit more subtle, and I think it's just a little bit trickier overall. So if we're working with y equals f of g of x, so we have some composite function that we're working with here, the first thing that we need to do is we need to identify an outer function, an outer f of x, and an inner function, g of x. Sometimes I'll call these an outside function and an inside function. So you want to identify an outside function f of x and an inner function g of x. G of x here in this case, I'm going to call that u for the purposes of our problem, and so that we can use this notation that I think is really nice. The other thing I'm going to say we should do here is we should find g prime of x or u prime, just depending on your favorite notation. I would also suggest finding that as well. So there's my first step. I just kind of need to pick this composite function apart into two smaller pieces. And this, I think, is the trickiest part. Once we kind of get used to picking out that outer and inner function, we can sort of rely on this formula, and I think it's a little bit easier to look at. But I think kind of picking these functions apart is a little bit tricky at first. So there's my first step. Step 2, what do I want to do here? I want to replace that g of x with u, so that you have y equals f of u. So at this point right here, you should not have anything in terms of x. What you'll have is you'll have a simpler function in terms of u. So you should not have x anywhere in your equation whatsoever, because that x lives kind of inside of this u. So all we're doing is kind of rewriting the expression, and what we should end up with here is we should end up with something that's a little bit simpler, something that's a little bit easier to manage. Step 3, I'm going to calculate the derivative, which is y prime equals f prime of u times u prime. So here is where I'm actually applying that chain rule. And again, you could use all sorts of different notations. You could say dy over dx equals dy over du times du over dx. You could use f prime of g of x, let's say y prime here for this. Y prime equals f prime of g of x times g prime of x. All three of these, this guy, and this guy, they're all equivalent. They're just different ways to write the same thing. Again, I think that this is the one that I'm going to lean on the most, just because I think it's the easiest to digest and the easiest to understand. The last step is just a little bit of substitution. We want to replace u and u prime with g of x and g prime of x, respectively. So what we're doing here is we're taking our function, which should still be in terms of u from earlier. We're taking our function, which is in terms of u, and we're kind of rewriting it so that it's in terms of x once again. So it's really following these 4 steps, and I do honestly believe that this step right here is going to be kind of the trickiest one. So we're going to look at a lot of examples in this section to make sure that we hopefully feel a little bit more comfortable with this by the time this lecture is over. So let's just hop into some examples. First up, I've got y equals cosine to the 5th of x. This one is, I actually think, is even a little bit trickier because we're not used to seeing cosine to the 5th. Maybe you are, and if you are, that's great. But remember that this really says cosine of x, that whole thing raised to the 5th power. We don't often write it like this. More often we'll see it as cosine to the 5th of x, but this is what it's really saying. It's saying cosine of x times cosine of x times cosine of x times cosine of x times cosine of x. So our first step, we said we want to identify your outer function and your inner function. And really, to me, I think it's that inner function g of x that's really, really important. That's the one that I care the most about. And I think once you find that inner function, the outer function is pretty straightforward. But the inner function, usually, not always, but usually if you have parentheses in your problem, as we do here, those are a really big hint as to what that inner function should be. So I think I'm going to take my inner function, my inside function, to be cosine of x. So off to the side here, and I'll number my steps here so that we can kind of follow along. I'm going to say u is equal to cosine of x. So okay, I found u. I also want to find the derivative u prime. So u prime, derivative of cosine, we said that was opposite sine x. So there's my first step. Honestly, I don't even need you to necessarily identify f of x quite yet, because we'll do that in the next step. This is really what I want to see right here, is I want to know that you've identified u and u prime. At least at first. As we get going with these, I don't necessarily need to see this step, but I think when you're very first starting off with the chain rule, this is a really, really good step to take because it is tricky. So I've labeled my u and my u prime. Step 2, well, what do I want to do? I want to replace g of x with u. So I'm just going to take out whatever I said u was. So u was cosine of x. I'm going to take out that cosine of x and replace it with u. So y equals, y equals u to the 5th power. So there's my expression, and the goal here is to end up with something that's simpler than what we started with. And you can even kind of look ahead. In the next step, we want, and let me erase it just so I can re-highlight it. We said we want f prime of u times u prime, which means I want to be able to take the derivative of this function. So the goal here is to kind of break this function down, take this one complex looking function, break it down into two smaller, easier to work with functions that we know how to take the derivative of. So I know how to take the derivative of u to the fifth. That's just a power rule. Derivative of u to the fifth, that'll be 5u to the fourth. So that's how I know I've made a good decision for my u. If you can't take the derivative of that result, then you either need to go back and re-examine your choice of u, so maybe you need to pick something else for u, or you just need to double check and make sure that you plugged it in correctly. So okay, I know how to take the derivative of this, that's good. Third step, I'm going to find the derivative. So y prime, I'm going to go ahead and take the derivative of u to the fifth. We said that was 5u to the fourth power. But then every single time we're going to be multiplying by this u prime. So I always like to just say times u prime. I think that's a little bit easier. If you want to go ahead and multiply by negative sine of x, you can. But we're going to be substituting in the next step. So I just say, why don't we do all of our substitution at once? So in every single one of these chain rule problems, we are always going to be multiplying by u prime. Every single time. So there is my third step. My fourth step, I simply want to take this expression. If I started with something in terms of x, I want to end with something in terms of x. So I'm going to take my u and my u prime, and I'm going to plug those back into my function here. So I'm just going to rewrite this function in step 4 so that I have y prime equals 5, we'll say cosine of x all to the fourth power, times u prime, that's negative sine of x. And maybe, okay, we can rewrite it or simplify it just a little bit. Maybe we'll say that this is negative 5 sine of x times cosine to the fourth of x. And there is my derivative. So it's a little bit trickier, I think, especially just with this picking apart your function and rewriting it. I think that those are kind of the trickiest parts of this chain rule, because it's not quite so simple as, oh, well, you just plug in, your numerator and your denominator into this formula. So let's look at some more examples here. So notice this one's slightly different. Earlier, if you scroll back up, we had y equals cosine to the fifth of x. Here I have cosine of x to the fifth. They look really similar, these two functions, but they're not the same. And I did that intentionally just to show that, hey, your inside function, if we change it, if we tweak our function just ever so slightly, that inside function can change. Because now, in part B, when I go to find my inside function, right, my first step is going to be to identify my u. This time, I'm going to pick x to the fifth. Again, keeping in mind that parentheses, while not the end-all, be-all of choosing your u, I think it's a really, really good hint, especially when we're first starting off. So I'm going to pick u to be x to the fifth. And right underneath it, let's find u prime. I know we're going to need it. That's 5x to the fourth. All right, so I have my u prime. My second step then is to rewrite this expression in terms of u. So y equals cosine of u. And ask yourself at this point, do you know how to take the derivative of this function? Well, yes, we know how to take the derivative of cosine. The derivative of cosine is negative sine of u. So let's do that in our third step. We're going to take the derivative. So y prime, derivative of cosine, we said is negative sine of u. And then every single time we said we're multiplying by the derivative of that inside part, by the derivative of u prime. Last step then, I'm taking my u and my u prime, I'm plugging those back into my function. So y prime is equal to negative sine of x to the 5th times 5x to the 4th. We could leave our function like that. To be honest, usually we write the polynomial part first, so I'm going to do it just because otherwise it's going to bother me. Negative 5x to the 4th sine of x to the 5th. But as long as you kind of make it clear that we're multiplying those two things, I don't necessarily need to see you rewrite it. As long as it's clear that we're multiplying these two things and this 5x to the 4th is not inside of your sine function, then we'd have a big problem. So there is my derivative. Let's keep going. Let's look at another. Next up, I have y equals 5x cubed minus 7x plus 9 all to the 10th. Again, first step, what is your u? What's your inside function? I see those parentheses, so I think I'm going to pick 5x cubed minus 7x plus 9 as my inside function u. So u, that'll be 5x cubed minus 7x plus 9. I know I need u prime, so u prime is 15x squared minus 7. So I'm going to take this expression now, I'm going to take out whatever I said u was, so that was 5x cubed minus 7x plus 9, and I'm going to substitute u in. So my second step, I have y equals u to the 10th power. Well, this is nice. I know how to take the derivative of that. It's a nice, simple little power rule. So, okay, my third step, y prime, will be 10 u to the 9th power times u prime. So the fourth step then, y prime, well, let's rewrite this. 10 times u to the 9th, so times 5x cubed minus 7x plus 9 all to the 9th power times u prime, that's 15x squared minus 7. If you really, really wanted to, you could take this 10 and distribute it way over here to the 15x squared and the negative 7. Honestly, I wouldn't even bother. You cannot, however, distribute this here to the trinomial because of that power of 9. We cannot distribute it. So, to be honest, I would just leave my derivative just like that and say, you know what, that's my solution. So every single time you can continue to use this four-step process, or if you kind of look at what's happening every time, we take the derivative of that outside part. So if I look at y, kind of go back and look at part B here for a moment, the derivative of cosine is negative sine. So let's look at this. Derivative of cosine is negative sine. Inside part, x to the 5th, that part stays exactly the same. We just multiply then by the derivative of that inside part, by the derivative of x to the 5th, and that's how we come up with 5x to the 4th. And that's going to work. Whoops, dropped my stylus here. You can use this idea for just about any chain rule. Look at this guy here. I have 5x cubed minus 7x plus 9 inside of x to the 10th, or u to the 10th. So, okay, we take the derivative of u to the 10th. That's really this guy here. So I'm just using a power rule. Multiply by my power. Subtract 1 from my power. Inside part, that inner function stays exactly the same. We just have to multiply it by the derivative of that inside part, which is how we get 15x squared minus 7. So I don't necessarily need to see you write out step 1, step 2, step 3, step 4 every single time. If that's how you feel comfortable doing these problems, then go ahead, continue to do that. But if you want to take a faster route through some of these problems, we can also say, okay, this guy right here, I will say, going to be a little bit problematic. Because of this right here, I have negative 8x plus 3 And I don't really have parentheses to help me choose. So maybe I'll take this and rewrite this as negative 8x plus 3 raised to the 1/3 power. Let's see if we can't do this problem both ways here. I'm going to see if I can take the derivative kind of really quickly using the idea that I just talked about, and then we'll come back and use the same 4 steps. We'll check our answer. So you still kind of need to identify your inner function here. Our inner function is negative 8x plus 3. That's our inner function. So okay, let's think about this. I have that negative 8x plus 3 raised to the 1/3 power. So if I wanted to take the derivative, I'm going to take the derivative of this outside part first. So I will multiply by my power and subtract 1 from my power. That would be negative 2/3. Inside part stays exactly the same, negative 8x plus 3. But we're using the chain rule here, so we need to multiply by the derivative of the inside part, which in this case is just negative 8. So if I wanted to, I could probably leave it like this, but if I wanted to rewrite this, this would be negative 8 over 3 times negative 8x plus 3 raised to the 2/3 power. So I'm going to say y prime, maybe? I don't know. If that seems too fast for you, though, then it's really no problem at all. Let's see if we can arrive at the same solution, kind of taking our time here. Let's say our first step, that would be this negative 8x plus 3. What's inside of the parentheses? So negative 8x plus 3. And I know I need u prime. That's going to be negative 8. So my second step, I'm going to rewrite my function. This is y equals, let's see, I'm going to take out negative 8x plus 3, so I will just have u to the 1/3 power. Step 3, I'm going to take the derivative using my chain rule. So y prime is 1/3 times u to the negative 2/3 times u prime. And then we'll take our u on our u prime and plug that back in. So fourth step here, we've got y prime equals 1/3 times negative 8x plus 3 raised to the negative 2/3 power times negative 8. And hey, look at this. This says exactly the same thing as what we've got right here. So we did, in fact, get the correct solution, taking this kind of abbreviated version, using this abbreviated version of the chain rule. So that's an option for you as well. I wouldn't recommend using this method that I used over here on the left-hand side until you feel very comfortable with the chain rule. So I would definitely practice some problems that just involve the chain rule. Just look at those. See if we can't get comfortable before you jump straight into trying to use this shorter method. Otherwise, it's really, really easy to make a mistake. And I didn't have one like this, but I want to do one more example here. Just one more example. Let's see if we can make room. No, I don't want to do that one yet. Let's do one more example. We'll call this E. Let's say I have y equals, how about 4e to the x squared plus 1 power. So this one is again kind of tricky, just like the last one was, because we don't have these parentheses to help us choose what that inside function should be. But if you've been paying attention every single time, u is always a function of x, every single time. So it only makes sense if I chose a function of x. Really, there's only one choice here, I think. It's x squared plus 1. It's really the only thing that's going to work for us. So I'm going to pick u equals to x squared plus 1. U prime, I know I need that. That's going to be 2x. So if I perform my substitution here, y prime is equal to 4e to the u. Oops, not y prime, excuse me. This is just y. I was jumping ahead of myself. This is y after I've rewritten it. I think it's because I wasn't labeling my steps. Here's 1, here's 2. It's a little bit confusing because here I'm going to take the derivative. The derivative of 4e to the u is simply just 4e to the u times my u prime. So on my fourth step, let's just continue on here. This is 4 times e to the u. Instead of u, I'm going to rewrite this as x squared plus 1 times my u prime, that is 2x, which if I wanted to, I could multiply 4 and 2x. Since they're both monomials, I would say 8x e to the x squared plus 1. So I just wanted to do one quick example involving an exponential as well. So again, I would highly encourage you to use this kind of 4-step method that we've established over here before you try to jump into this shortcut that we used in the previous example. I want you to get really comfortable using the chain rule before we try to start making any shortcuts, because I think that's a really easy way to make mistakes. So please just take your time and be careful with these problems.